Climate change is about energy. Energy is required to keep economies running. And economy is about money. Welcome to watch the Sustainability Trends in Business. This time we will discuss the interplay of climate, energy and money. We use a lot of money to get energy. If you remember, or you can see it from this chart, that 90% of primary energy comes from fossil fuels: coal, gas, oil. And there is a lot of money involved in fossil trading, of course. Just to outline these roughly, these change from day to day and from location to location, but in general, we use about 9 billion tons of coal every year. And the price of coal is about 150 euros per ton. So roughly it's about 1.2 trillion euros, 1.2 million euros a year. We use gas about 4,400 billion cubic meters, that is 4,400 cubic kilometers. And the cost of gas is about 45 euros per megawatt hour, or maybe about 45 cents per cubic meter. So we talk about 2 trillion euros altogether. A bit more than for coal. And then oil, 35 billion barrels a year, and it's about 75 euros per barrel, which gives 2.5 trillion euros. A bit more than for gas, but of course these vary a bit from time to time and place to place. But roughly, this is altogether about 6 trillion euros, which is around 7% of global GDP. So it's a very large sector. As there is a lot of money, it's important to understand who sells, who buys. And here is a chart for coal. This chart is a bit old, and it's from before the Ukrainian war, but there doesn't seem to be newer information available too easily. So the largest producers are China, India, the United States, Australia and Indonesia. Top three are domestic users, that is China, India and the US, but Australia and Indonesia are large exporters. Australian coal has been in wide use in the EU. It has been used even in Finland despite the very long transportation distance. But it's very energy intensive and you can put it in a ship, so transportation is no problem. And for some of these countries coal is important. For example, for Indonesia, coal is over 10% of its all exports. And here we have a similar chart for oil. Again, a bit old. Middle East is the oil hub of the world. Africa is surprisingly large. There are a couple of large producers, and Russia is a big exporter. The exports have now shifted from Europe to India and China, but then again it's sort of a trick, because then if you look at what has happened, then we get more of Middle East oil. So basically what happens is that they buy more Russian oil in India and China, less Middle East oil, which means that Europe buys more Middle East oil. There is no map for natural gas. That would be interesting. Russia used to be the largest exporter anyway by far, but now the position number 1 belongs to the US. Russia is number 2. And then next on the list, Qatar, Norway, Australia, Canada. Liquefied natural gas has become more popular because you can transport that by using ships, and Europe is using a lot of natural gas from the United States. Sanctions actually work here, and Russian gas exports have gone down because pipelines to Europe are not in use that much. Yes, they are used, but not that much. Now, by looking at these maps and this information, it's easy to see who will lose in decarb. Russia is one of the biggest losers because they are an exporter of oil, natural gas and coal, all three. But also Middle East countries, all countries are important, and Australia. And this can be seen in their policies. Well, Norway is a bit strange. Norway tends to play in both teams. It talks about emission reductions, but it rakes hideous amounts of money from fossil fuels. It's actually unsurprising to see restlessness around Russia and Middle East. Oil is not the only reason, but it's one of the reasons. As we try to get rid of oil dependency and fossil dependency, these countries will lose. But how about the renewables? The renewable capacity is not distributed the same way. Here is a map for wind power potential. Generally, ocean coasts, open areas, mountains are the best places. There is large variation. If you take Greenland, it has in average about 1600 watts per square meter, and it has a lot of square meters as well. Spain has only 200 watts per square meter. Typically, of course, depending on the location, you have more windier places. And this is despite the ocean. So it's not only the proximity to the sea. Finland actually is quite okay. We have a lot of areas with around 800 watts per square meter in many places. And here I'm talking about the potential at 200 meters, because of course the higher up you go, the higher potential you have. This image is from the Global Wind Atlas website. There is a lot of information available there. For example, the windiness on different heights. It should be noted that close to the equator it is generally quite calm. And here we have the solar atlas. Well, you wouldn't be surprised to see that there is more sunny areas close to the equator. But then you can see that cloudiness has an impact. Sahara is great, very sunny. Central Africa, which should be very sunny, is not, because it's very cloudy. And then India, the same thing. The Southwest United States is one of the best places in the world. Nevada, California, a lot of space and a lot of sun. And they are building a lot of solar panels in there right now. Europe is not so lucky. Europe is cloudy. And you can see that by comparing Germany or France with, say, Mongolia. They're on the same latitude but different sunshine. The nice thing about solar and wind is that there are very few places in the world which wouldn't have either solar or wind. By the way, at this point, a warning on map projections. These maps use the Mercator projections, which is very often used. It has true compass bearings, which means that north is up and is right, but it exaggerates sizes of areas away from the equator, up north, down south. Here you may compare it with the Molenweide projection, which keeps the areas equal. And you can see that we are not that big up north. But all map projections lie, because you cannot flatten a sphere on a two-dimensional surface. But this is important to understand when comparing maps. One very interesting possibility is that the lowering cost of solar panels combined with the lowering cost of batteries makes cheap and steady supply of electricity available in many places of the global south, because there are many sunny areas and the batteries can be used to tackle with a problem called night. So this may lead to a lot of good things. For example, it might be that people in the global south may just be able to skip a technology generation or two, and there will be more wealth pouring there because of abundance of cheap and steady electricity. On the other hand, that may not be that good news for us. Again, if the energy is elsewhere, as it now tends to be with the fossil fuels. Anything else regarding geography? Well, there are other geographic features which may be important. You have aquifers, oil or gas wells, and salt caverns. These are important because you can store either carbon dioxide or hydrogen in them. And this might be useful in the future. They are not distributed evenly. For example, Finland has none of them. Wet mountains, they are great for hydroelectric power. Anyone would like to have wet mountains. Then there are a lot of important minerals regarding electrification, for example lithium, but also copper, aluminum, and so on. But there is one thing to understand about resources. Resources are sort of in relation to the land area, but the number of users is the population. So population density has a lot to do with here. Just as a note, The population density of Russia is 8 people per square kilometer. The population density of Europe is 108 people per square kilometer. So even if Europe had a similar amount of natural resources as Russia, it wouldn't be that resource rich per person. Well, let's go into a local curiosity. Is Finland a winner or a loser in this game? We have no fossil resources, no oil, gas or coal. That might be a lucky thing as well. There are no places to stash gases, no aquifers, no salt caverns. This is a flat country, few mountains. We have hydroelectric, but it's flat hydroelectric river type of thing. And then we have awfully bad seasonality for solar. So a lot of things that are not in our favor. However, we have a lot of hydroelectric power in total. We have a lot of wind and we can use solar. It's quite sunny here. We have good know-how on nuclear energy. Finland is the first country in the world to solve the waste problem actually. And we have a lot of experience on process industry, petrochemical industry, which is important when you try to refine something useful out of hydrogen. And then we have a lot of forestry, which means a lot of biomasses and understanding how to handle them. So we're not a Norway, a winner of everything, but we will be a winner if we choose wisely what we are doing with the resources. So, a lot of money is in energy and there are a lot of geographic factors impacting the future and we cannot do anything with the geography, we just have to understand that. But this is all for this episode. Next time we will talk about carbon taxes and emission trading. See you then!